Hello, everyone. Welcome to the May 2025 edition of our Webinar Wednesday series brought to you by the Beckhoff USA product and marketing teams. I am Brandon Snell, the US MX System Product Manager, and today I will be providing you with some insights into our revolutionary new product, the MX System. We got a couple of our MX System experts in the background as well answering questions, so feel free to put your questions in the Q&A section, and as we move through the presentation here, they'll be answering those. Anything that we see that we can get to at the end, if we have time, we'll also answer a few of those questions live and go from there. So thank you for joining us today. Let's go ahead and get started. The agenda for today is to kind of go through the motivation behind the MX system and why we like the idea of the MX system and have kind of came up with the concept. What is the MX system as well, and how can the MX system be used? And then we'll wrap it up with some additional MX system related tools that are going to be able to be used as well. So that's kind of the agenda for today. But before we even get into the motivation, I'd like to talk about kind of the history of automation, because it's really important to understand, where we came from, where automation started, and kind of the challenges that we've had to deal with over the years. And I love this picture that we have on the slide here. This is a representation of the real old-fashioned belt and pulley, centrally controlled plant automation. Right? And you can even picture this, like it could easily be even a steam engine from the beginning of the Industrial Revolution, driving that central main drive shaft. And you got these belts and pulleys coming off of this guy. Just picturing this, a number of things jump out, right? Cramped space, very little space to get around a facility like this. All sorts of maintenance issues, extreme needs on the maintenance side of things, right? And not to mention the safety concerns that surround a system like this. I'll give you another real example from this. Is if you have a machine, let's just say second machine in the row here had some sort of trouble. Back in this day, to end up doing any maintenance on that, you'd have to take this pulley and pop it off the main shaft and put it on like an idler pulley, right? To be able to stop that machine to do any maintenance on it. Just that part alone is a safety concern that we have to deal with, right? So the complexities of this, that centralized control, there had to be a better way, and there was, right? So we made some changes over the years, and we moved into kind of the electrical age, right? Being able to control things from the electrical standpoint. This is a nice, like older picture of one of the first PLC controls. Kind of jumping over the history part of the relay logic, right? Obviously, that was where we started with the electrical side as relay logic, but then jumped into the PLC control side of things. And this helps, right? It starts to decentralize things. Right? We don't have this machine being controlled by some main control panel in the central part of the plant. It's its own machine that has its own disconnect, as you can see up here. But it's also, bringing in its own set of risks when we move to this side of things as well. And not only the risks, but also a lot of work, right? It didn't really solve some of the complexities. It just moved those complexities from a mechanical standpoint to an electrical one. If you look at all these, discrete wire connections in the terminal strip on the side there, it's all right. It's where we started in this side of things. We got push button boxes and valves out there. They get wired back to this box. But again, we got to think about things like the safety aspect as well. One of the things that jumps out at me here is I sure hope he's not doing anything to work here with that power on, with that disconnect on, because that just seems like a quite the hazard electrically, right? And we've had to deal with this as people in the industry. We've dealt with these concerns for many years now. Um, so what have we done recently? Well, honestly, not a lot has changed on that recently, right? We still have these large cabinets. We still have terminal strips with a bunch of wiring going to those that has to be very particularly put together. We may have smarter components. Don't get me wrong there. We've got smarter components that minimize some of that wiring using Ethernet based protocols like EtherCAT to connect between modules. We're moving in the right direction there, but we're still dealing with this large cabinet. Still dealing with complex designs here, and as this shows, potentially a decent sized team just to wire up and troubleshoot a cabinet. And kind of back to the hazard side of things too. We've got to make sure when we're dealing with these cabinets that we're taking care of the electrical side of things if we do happen to have the doors open, right? That's a big deal. So history wise, that's what we're seeing. And if we look at it maybe more from a Beckhoff specific history, what have we at Beckhoff been doing over the years to try to address some of this, some of these things? We started way back with our first PC-based controls back in 1986, and by 1995 realized, hey, we needed the right kind of setup for dealing with these input and output devices, getting those signals back into that PC-based control. So that's where we came up with the bus terminals. As you can see, very quickly after that, within 3 years, we came up with our first set of devices that would be moving things out of the cabinet, the field bus boxes. So that's our first kind of foray into moving something that was in the box that was complex and dealing with that and moving it out to the machine closer to the signals, right? We knew that was a good step forward. Of course, we jumped forward to 2003 with EtherCAT, and at the same time, we started working in our field bus boxes as EtherCAT style boxes. So we've got our EP version of boxes there, and continued to start moving things outside of the cabinet. Our multi-touch panels in 2012 with the versions that are fully enclosed available then. So getting that off the side of a cabinet in those cases. And more recently, adding in our distributed motion with the AMP 8000, so moving those servo drives, which is one of the biggest things that are inside of a cabinet, especially from a heat standpoint. Moving those outside of a cabinet, and even so far as moving the PC itself. In 2019, we announced the C7015 PC that's able to be moved outside of the cabinet. So all of these things have been leading up to our present day, which is the MX system. So that's, before I got to the motivation, I really wanted to kind of go over that timeline, right? I wanted to talk about where we came from and why, now we kind of get into why that makes sense and why we're moving into this idea of the MX system. We kind of start that conversation with the idea of what challenges are we seeing in the industry that really motivate us, right? What is the motivation? That's the point. And these four that you see on the screen are the big ones that we're really noticing quite a bit. The first on the left there, right, that machine cost optimization concept. Around that, when you're building machines, when you're putting together plants, we're always worried about the cost of the equipment, but not just the equipment, right? Also the cost of labor, or the cost of people's time is very important. And if you've been, in the industry at all, especially in the last, 5 to 10 years, the cost of labor is going up. The availability of labor is kind of dwindling. Finding skilled labor is very difficult these days. So that's all part of that cost side of things. But it's also, the skilled labor side of things is also part of the development side of things, right? Finding skilled engineers that can design systems that can make them efficient systems to put together. On a development timeline, also just a matter of building these machines and shipping these machines out. It's very important. So those two top motivations there are things that we think the MX system can help with, and also on the bottom right, uh, just from the nature of the MX system. Right, I started off by calling it a kind of a revolutionary product. Right, this type of product, like the MX system, is something that can help you as a machine builder or as an integrator or even the end user out there, can help you maintain that competitiveness in your market, because it is something, as you'll see as we go through this, that can allow you to have that edge when it comes to the automation side of things. And we also think that quality control and support is a huge challenge in the industry as well. Right? Having the quality components installed and reliable components installed, and also being able to support those, whether it's remotely or support it from a standpoint of hopefully you don't have to do a ton of work on it because it is so reliable in the first place, right? These are kind of some of the big major challenges that we're talking about. And so let's kind of look at a little bit more into these challenges. And I bring this picture because I think it's obviously a bit of a large setup, a very complex design. So it makes a statement, right? It's like, hey, look at how much effort goes into this. And let me ask you a question there, right? How long do you think it took to simply build this system? To put all these components on backplanes, wire all these up. I mean, the ground wires themselves, getting those to the right length and to the right places, significant amount of time. Days, weeks, who knows for sure how long something like this would take. But not only from a build standpoint, the design standpoint of designing this system, even the purchasing side of things, coordinating all of these different components and getting them from the right suppliers, right? It is a hassle to put all of this work into a system like this. And is this real, right? This type of system, maybe this is a bit of an exaggeration. Well, honestly, in certain industries, I've seen in the interlogistics industry, for example, 4 or 5 cabinets sitting on a wall with a lot of this type of stuff in it. So it is a fairly realistic example on what we've got. But maybe you come from a bit smaller of a machine standpoint, and maybe you're working with a plant floor layout that you've got to fit your machine into, and that's this kind of idea is the same, more along those lines, right? It's a smaller cell, but there's still a lot to look at here. You're usually given a small footprint to fit your particular machine cell into, and you've got to find ways to make that happen. You can see here one of the ways that we've seen as kind of a trend more recently is to simply move the cabinets up and out of the way, because they take up space, right? So if we move them to the top of the machine, for example, that gets them out of the way. It saves you some of that surrounding floor space, but you still have challenges. I mean, the accessibility of those cabinets right there alone is something that I see from a maintenance standpoint can be quite a problem. But that's where we're at, right? The size, the lack of space pushes us into this. Doing something like this ends up giving us longer cables that we've got to deal with, right? And a number of other things here that we add to the list, right? It makes it more difficult, more labor intensive, makes it more complex again. So it's just that's a lot to think about when designing these systems. So that's where really, that's where the MX system comes in, right? And what does this really mean? How do we move forward into something that is this innovative or revolutionary product? How do we move forward into that to maintain our competitiveness and reduce our footprint, that type of thing? Well, what we do is we take what's in this cabinet, we find the different components, and we transform them into a system like this, the MX system. If we look at this system right now, there's a number of things in this cabinet. Fuse holders, for example, power supplies, your I/O section. All of these things, we've got to find these things and put them into modules that make sense over here. So that's what the MX system does, right? This product line takes what's in the cabinet and does one of two things, really. It encapsulates the functionality into a module with a purpose. Think solid state relays for heater control, for example, or maybe servo drives, right? Or in the case of terminal strips, we simply eliminate those components. So when we take this and we compare it, what we really want to see here is how does that affect things? Take our cabinet and we say, okay, we overlay our MX system, but wait a minute, that's not quite to scale. So let's scale this just right. That's more along the lines of what the MX system really is doing. So let's do a little comparison before we get too far into this, because I think that's really interesting and there's a lot to say about that. And I'll let you read this table. There's a lot to digest in this table, but I think some of the important ones, right? The size alone, by volume, we're reducing over 90% in this one example here, and that's fairly common to be reducing our space needed for the MX system, to reduce it somewhere up into those 90% ranges. The weight as well. I mean, 60% reduction in weight. And again, I'm not going to go through every single one of these, but the other ones that I wanted to point out from my design my design background, 92 pages down to 24 pages of electrical drawings. That is saved work right there. I would have absolutely loved being able to save that much of time and effort into making sure the drawing package is right. And that also eliminates a number of things that I could have messed up in my design, right? Anytime there's an additional page, that's another cross-reference number that I'm potentially worried about, that I didn't get quite right and sends it to the wrong thing. So anytime you reduce that amount is a huge deal. Another one that's really, I think, important, we'll talk about more in this presentation, is the EtherCAT side of things. We've got EtherCAT connection to all of the components, right? So we get a simpler installation, a smaller installation, and a smarter installation with the MX system. So, all right, we've talked about kind of the background. We've talked about the motivation, why it makes sense to do the MX system. Let's learn a little bit about the MX system as well, because I think that's part of the reason why you all are on the call here today. So if we dig into the MX system, right, the kind of the backbone to all of it is the base plate. So when you look at the MX system, we've seen a lot of pictures so far where it's showing all these components, kind of a standard form factor there. The base of all that are these base plates. Right now we're looking at these three different styles. So a single row, which is mainly for your low voltage, 24 or 48 volt distribution. We have a 2-row and a 3-row that we then get into when we have higher voltage. So if we have our 480 volt AC for example, high voltage servo drivers, that type of thing, or a 3-row when we need to get even more room available for us. These are kind of the backbone to everything. But other than looking at a picture, right, what does that really look like? It comes down to kind of two main things: a data slot for the data connection and the low voltage, and a power slot for the high voltage connection. So the data slot gives us that EtherCAT communication. It distributes our 24 volts and our 48 volts in parallel across the base plate, so that that's available if we happen to have the 48 volts. Having that across the whole thing in parallel with 24 is a big deal. And then on the power slot, it's the same concept, right? It's your three phases of your 480 volt with neutral and ground available, and your plus and minus DC for high voltage DC on that power slot, distributed across the entire base plate. And what does that really look like? I think this maybe paints that picture a little better, in that there's a board in the background that's taking care of that power distribution. But really what's important on this one, I'm not going to detail all these pieces of it. You can read that part. But what's really important, I think, here is the EtherCAT side of things. I said I'd come back to that, and this is where I want to really highlight this. Is if you notice, there's a chip at every single one of these slots. So this is how we're achieving that 100% EtherCAT. So that every device that's plugged in is going to connect into that data slot. It's going to have an EtherCAT chip connected to it so that it can facilitate that communication. And we also then have this kind of the housekeeping thing on the side where it collects data on the base plate itself, the temperature, shock and vibration, dew point of data on the base plate. So it's really the base plate itself is actually quite an interesting piece all on its own, in that it brings in all of this data, provides that data up to you. But really the next piece, right, the next part that's important for the MX system is the housing of these components. And the thing that we tend to highlight, I think, first out of the gate on this a lot is the rating, right? The IP67, IP65 protection class with that double sealing principle for the rating. And you notice I highlight IP67 and IP65. I think it's important because honestly, there's a different test for 65 than there's for 67. And just because you pass 67 doesn't always mean you're going to pass that IP65 test. So we want to make sure we covered both, and we did. Right? We covered both. We did the IP65 test with the the jet of water, which is part of that test, and then the IP67 is a submersion test for a period of time. So it is important to understand that that's rated for all of that. It is truly rated to handle these harsher environments. And that's where some of the rest of this comes into play, like the oil and detergent resistant, right? That kind of speaks for itself. The passive cooling, we'll see that, and we'll talk about that a little bit more in a minute. But then this kind of the last one that maybe is a little unique to some of you all, it's the passivated and painted or chrome plated characteristic of this housing. The idea of passivation, right, is to create a protective layer to shield from corrosion. So that's in some of these really harsh environments. That's important, is to have that protective layer there to prevent oxygen and moisture from reacting with the metal and causing problems there. So we really did, from a housing standpoint, think of a lot of the things necessary to make sure that this is going to work in your environment. The next side of that too, and this is where I'm getting a little bit more into that passive cooling side of things, is the characteristics of the each unit's house as well. So from the small little I/O side all the way up to the servo drives and the disconnect modules, they all use these different pieces that are used to encapsulate the functionality. The big key here is that the base of all of these modules is using a zinc die-cast method of material, right? That zinc die-cast is used specifically for its high dimensional accuracy. And if you think about that data connector that we talked about already, the pins that are on that connector, we don't want to have to worry about whether you're lining those pins up perfectly every time. That shouldn't be your concern. You should be able to take this module, plug it directly into that base plate, and be able to immediately start working with it and not having that concern. So by using the zinc die-cast for high dimensional accuracy, we can guarantee that it's going to seat properly when you plug that thing in without you having to really worry about it. Again, things like this are what we put the effort into the MX system to understand. But obviously, zinc is not necessarily your best conductor of heat. That's where we get the next part of the housings. That's all in the aluminum with the heat sink fins on the side. So using the combination of the two really makes for a powerful setup. So how can we use this system? And before I maybe jump into that, just want to address why did I only talk about the base plate and the housing? Well, part of that is because the MX system is built on existing technology. Right? We at Beckhoff have been doing automation for a long time. We've got PCs that we've proven in the field, servo drives, IO, right? All of these things are stuff we've done. We've proven that. This is just a new housing for that same technology. So, if we want to get into the details, this is something we're looking forward to having those conversations and talking about what exact pieces we would put together. But let's look at it from a bit of a higher level from how. Let's say you've got a small machine, super simple. Maybe it's even got 120 volt AC input, single phase. And all it's doing is some compact motion, maybe some 24 volt steppers, a little bit of IO. Can you use the MX system? Absolutely. Right? That's what this system here is. In this case, highlighting a few things that are in the picture, right? You got your PC for your control, your IPC there for control, power input here for your 120 volts, little IO, compact motion, and then even branching out from that with our EPP, so the EtherCAT with power out to those boxes for some remote IO, right? And okay, you've got a simple machine, but from a development timeline, this still makes a ton of sense. I mean, think about the time it takes to source all of the different components that you have to put together to get something like this to work. All the wiring, the panel, the cabinet, potentially cooling this thing, because a lot of times these compact machines end up having to go in an even smaller location. And then of course it's helps you innovate. I look at this one and I compare it to, in the past, the move from these custom PCBs and that being part of your design to, say, jumping into off-the-shelf PLC IO and drives type of design. I look at this as that next step to that, right? Because that was a difficult step for some to say, oh, I'm not gonna worry about my PCB and all the chips that I have to source to make sure I have the exact same PCB every time. To be able to say, I'm gonna go to the PLC world where it's just off the shelf, then I just plug things together. Well, this is that next step, right? We then say, okay, let's encapsulate that functionality into these modules to save you another step. So, all right, as a compact control, I think I probably talked about that enough. What next? What else? Well, maybe it's still a bit of a compact machine, but it's let's say a packaging machine in this example, right? So we've got a little higher voltage, got our 480 volt 3-phase input. We've got some 48 volt compact motion drives in this case. So we're still, this example here, still not using the high voltage DC side of things that you may be used to. It's still the compact motion. But what's interesting here is we've added these relay modules for heating. And I think this is a good chance to talk about one of our modules, which is our solid state relay module, and explain what I've mentioned a few times. This idea that what we're doing is taking components that are related to each other and putting them into a module, not just a module, but a functional module. This solid state relay module is exactly that. It encapsulates the fuse holder and the fuses. It encapsulates the solid state relay itself. But not only that, it encapsulates the feedback needed for that heater control. So a thermocoupled or RTD feedback, all in this one module. So think about the design time and the wiring time that goes into putting together a heating section of a machine, where now we can send say an M12 cable out to a heater and an M12 or M8 connector back to a connection here for feedback, and we're there. The rest becomes plugged in to the setup, providing the power to the disconnect, and programming it. So fairly straightforward and simple when you encapsulate that functional module. The other side of this too that we can highlight on this one here is kind of the combination of that standard and safety IO. So keeping in mind that we're building on our existing technology. We've been talking about twin safe for quite a long time now. We've got hardware out there for the twin safe side of things. That same concept works in the MX system as well, right? Whether that's the IO side of things or whether that is safe motion capabilities. It's all integrated, kind of optimizing your design, right? And optimizing your build process. But let's say you got a bigger machine, right? Let's say it's a CNC machine, for example. That takes it's got a main axis that is a fairly high powered axis. How do we do that? Well, this is where we've stepped up now to the 3-row base plate. Got a bigger disconnect now that supports up to 63 amps. We got a bigger DC power supply to provide for our feedback or our servo drive. That's that high powered drive there, and multiple axes on the same base plate. Whether those axes are servo axes, whether they are spindle axes, could be just simple motor starters to run a pump, for example. All of those are possibilities with the MX system. And something to highlight here too is when you start getting bigger machines, larger footprints, the last thing we are wanting to do is say, hey, centralize everything on this MX system. We don't want to do that. We want to continue to push this decentralized, distributed kind of architecture. And that's why we're highlighting these EP boxes, right? You might have a light curtain out there. You might have a door switch that's on safety. We can put remote safety boxes. Whatever device, it makes more sense to put that on EtherCAT and have that either single cable on EtherCAT or cable and power on EtherCAT and power coming back. That is the point, right? We're wanting to move to that distributed side of things. And speaking of distributed, really, how big can we go? So keep kind of building up, right? How big can we go here? And this concept here is, as you can see, 125 amp input. And it's really treating the MX system here as a power distribution system. Think about, again, the boards that are running this in the background. We've got a data board and a power board. So it's really what it is. It's distributing power. It's distributing communication and low voltage power as well. That's the idea. So here we're bringing in mains power. Maybe we've got our PC that's controlling everything. And then we're distributing it out across whatever this large machine or large cell or part of a plant network might look like. We're doing that with EtherCAT, obviously. So we've got our EtherCAT inputs at the start of every single one of these base plates to ensure that EtherCAT communication goes through it, and then distributing that power. And one thing to really highlight here is the way we're using these base plates. So you'll notice on a few of these, we have some empty slots that are just covered up, especially on the bigger base plate here. That's totally fine. We've got that EtherCAT communication chip on the board to say, hey, I know there's nothing here right now and it's covered. But we're also utilizing the second row to do some data communication in order to keep us from having to go another 4 wide and waste a bunch of aluminum and waste a bunch of space and that type of thing. So we have some versions of these that will work where it kind of wraps that communication around. So this is kind of an extreme example, right, of how to use the MX system, but it's a completely valid one. We have an example a little further in this presentation to show you an actual real world example where we're doing pretty much exactly this. on a real machine. But let's say you just want to get into the MX system, but you've got an existing machine design that is really well proven out. Maybe you've got a year's worth of components on the shelf that you pre-bought because you're worried about lead times or something. So you've got all this stuff you're needing to build, but you still want to try the MX system. That is totally fine, right? What do we need to end up having an MX system backplane work? We need power and we need communication. That's it. So we have a module where you can bring in EtherCAT and you can bring in your 48 or your 480 volt AC into that module and use that as a part of a system that exists, right? So more of what we're calling a hybrid configuration. I think it's really really a nice thing to understand that this can then be part of an existing system like that. So if you needed to add a module on, add something to the machine, it can be the MX system baseplate to do that. Using then the controller that's in the main cabinet. You still have the drives in that cabinet if you want, right? This whole setup, it totally makes sense, and that could very well simplify your design and your execution of that machine by not having to go through and build another cabinet like this, right? But obviously, you can switch back the other direction too. So this can be right in line. This is kind of what we're showing here, providing 480 to this guy, EtherCAT communication to it, and now we're back into the traditional cabinet. Totally fine, right? These are the kinds of things that we want to talk to you about and work on and say, does this make sense? And I think the other thing to highlight here too is not just EtherCAT, but EtherCAT P capabilities coming out of this system, working with everything that you're used to, even if it's third-party devices that you're used to putting on EtherCAT, right? It's all part of kind of that Beckhoff ecosystem of components, that full portfolio. So let's take a look at an example here. So this is a nice little video that shows a rendering of a machine. And the main thing that I really want to point out here, I keep talking about the MX system, but what I haven't said is, what does that even stand for, right? The M in the MX system stands for modular, and that's what we're highlighting here. I talked about the power distribution. You can see that kind of main panel there. But then you can see here, as we kind of scroll across, all of these modular pieces of this machine. Each one of these sections, as you'll see in a second, ends up coming apart and being its own kind of discrete section of the machine that can be built by itself. It can be then tested and proven out all on its own. See how it kind of separates there, and we'll zoom in here on it and talk about a little bit. We'll see the real, right? Switch to the real view of this now. And I think something to maybe notice, right? It's like these little boxes right here. We really are utilizing existing components. We really are integrating some of these third-party devices that we've seen before. So this is again, it's a real application that we have testable and it's accessible, and that's really where we're getting at. This is it's a window profile machine manufacturer in Germany that's been working with us as we develop this system, right? And I think the key to this kind of talking point here is back to one of those challenges. It's that quality control and support side of things. So the guy that's in charge of this company, one of the things he likes to point out is that he can build each of these modules, as we were talking, modular machine, build one of these in pre-assembly, right? And prove out each section of these machines in pre-assembly before it ever gets to the point of like, I have a full machine built. And that way, when the order comes in for a real machine, he's got these modules ready to go that we can bring together. We can plug the cables in. We're not worried about each module and how they work. We're just at that point just making sure everything works together as a full system. The other side of it, And this is something that's usually pretty easy to see in a picture like this. If you've done any machine design, if you think about these servo drive controls that we're seeing here, dual channel, what do we got? 2, 4, 6 there, 8, 10, 12 drives probably, or 12 motors connected. Some of these low voltage versions as well, the compact motion. There's a lot right there. Just think about the size of the cabinet, all the wiring that goes into that. It's going to be pretty significant. It's probably going to take up the majority of the backside of this machine here, which then makes accessing the insides of this machine more difficult. So not only is it that we're making it easier to access the control side of things, we're making it easier to access the actual mechanical setup of the machine by moving to the MX system. And also, and I keep saying that, right? Adding to this, right? Also this and also that, right? It's more accessible in general. One of the things that when I look at a picture like this and I think of a big machine, I think about what happens when there's a fault on the machine, when something goes wrong. Typically, something goes wrong at a customer. They've got to stop everything, and they want to know what caused that problem. Well, if it's something that requires you to really dig in and troubleshoot from the electrical standpoint, you've got two options. One option is to take all the safety precautions you can, suit up in a big suit, more than likely for arc flash protection type things, open up a hot cabinet and start poking around in there trying to figure out what's going on. Or maybe you take the safer option and you actually shut things down and power off sections of the machine so that you can get in and look at the cabinet, or you can open the door without extra precautions there because you know that the power's been taken care of. Those are kind of your two options, and honestly, both of them don't sound great. Well, here, we can just come around the backside of the machine and we can take a look directly at the components. We can see the status of those components. We can see if somebody unplugged a cable, from the EtherCAT side of things and dropped communication. We can easily access that information without having to go open a cabinet and change the state of the machine, right? We can really troubleshoot this machine in the state that it was in. So that kind of brings me around to the additional MX system related tools, right? This is the one that I'm pretty excited about, getting into the extra tools here. The Beckhoff diagnostics app is something that, if you've seen anything about the MX system, we've talked about this a little bit already. But I think what's interesting here is to point out the details behind this, because the MX system diagnostic is handled by a Bluetooth dongle. And now, if you're like me, you hear Bluetooth and you go, "Oh no, that doesn't sound great. I'm no way the IT guys at these places are going to let me plug a Bluetooth dongle into the PC and give another connection into that. No way, it's not happening." Well, that's fine, because that's not what we're doing, right? As you can see here, this Bluetooth dongle actually connects directly into the base plate, straight into EtherCAT. It is an EtherCAT device as well. And inherently with EtherCAT, we've got kind of that security side of things taken care of. So that's where I think it's kind of a nice change of pace there, is that we don't have to worry about the PC. It's not giving you any direct access to the PC. It's giving you access to the EtherCAT side of things. And maybe the more important part of that too, because then I start worrying, okay, you're giving me access to the EtherCAT, and what can I do to it? It's still just a read-only interface as well, right? You're not taking this diagnostic app and going in and toggling outputs or anything like that. It is intended for diagnostic. And we'll take a look here. Kind of got a nice little video that overviews this. This is a screen recording we did with an iPad that was connected to it, right? So this application will be available for Apple and Android both. Works on an iPad or a phone, right? As you can see, we're digging into a decent amount of information here. And we're even adding, in this case, from the eFuse side of things on these modules, the current that module's pulling, that the eFuse is seeing. We're adding it to a scope. so we can visualize that information as well. So there's a lot to this app. There's a lot going on. I mean, you can get in and see wire break detection if that's a available thing on that module. Just so much diagnostic capabilities here. And then you can run the scope to kind of give you an idea of what's going on with the signal. Now keep in mind it's still just over Bluetooth. It's not a millisecond style scope, right? That's where our TwinCat measurement projects, that product line comes into play. If you really need some detailed information about a signal, let's look at the TwinCat measurement side of things for that. But for this, just to give you a pretty good idea of what's happening with that signal. So with all that, right, this brings us back to a familiar picture from the beginning. Why the MX system? I think when we've gone through this conversation today, we've talked about that cost optimization, especially from the labor standpoint. But if it was missed, maybe understand that cost optimization can come from anywhere, right? It can come from not just the labor side of things, but it can come from simplification of a machine. It can come from making it easier on the purchasing agent to find these parts because it's a single part instead of 15 parts to make a solid state relay from that example, right? It's optimizing that and making it a more streamlined process. And from that streamlined process, the development timeline as well. Not having to really dig through all those pieces to really put together a system. The development timeline, I think we're solving that, right? Solving the optimization. We're solving development timeline. We're solving the innovative, maintain the market competitive side of things. Bringing in a product that is new, that is innovative, that helps you to minimize your floor space, to be that market leader and build those machines quicker, right? These are all kind of building on each other. And then with that quality control and support, right? We talked just now about the diagnostic app, and that's a great support tool. But we also talked about quality control when it comes to the housing characteristics, that zinc die cast housing, making sure that it's quality connection every single time. Having EtherCAT to all these devices gives you that quality control, so you know what's happening at all these devices. So I think I've covered all four of those. I hope you understood where the motivation was, what type of applications make sense, how we can use the MX system, and I hope you learned a little more about how the MX system is put together and what it uses to make this a true cabinet-free design. I'm gonna see if I've got any questions that make a lot of sense here to cover. So, this is a good one. So can I have access to the diagnostic data by my HMI or PLC? So that's a great point. And I think I highlighted the idea that this diagnostic dongle goes on the EtherCAT EtherCAT network. So you're getting that data from EtherCAT. But what I didn't point out is that same data that obviously then would be available to you. So it's just a matter of pulling it in to the PLC code, and you can do something with it there, or presenting it up on the HMI, and that's where the HMI I think comes into play and gets a lot done. Let's see if there's another one here that's really good. I think there's some other pretty good ones here. This is an interesting one. We've talked about the IP67, IP65 rating. The big question here, whether it could end up with an IP69K rating, and that's difficult, right? To get IP69K with the heat dissipation side of things. I think that's a difficult one. It's something we've talked about on whether that's a possibility or not. But at the moment, that's not something that is on the initial rollout. This is a really good one too. I think this is maybe really important to highlight. The question here says, do I need to rewrite my PLC code when I switch from a standard product system to an MX system? And absolutely not. PLC code wise, it is still TwinCat, it's still the same PLC code. The major thing that changes for you in your TwinCat project is the I/O structure down in the bottom. And actually, with the use of if you've heard of our variant manager capabilities, the use of the variant manager can make that simple to switch from one back to another and back and forth, right? Those are all kind of a really this really good point, is to be able to do that. Here's another good one. Is I didn't talk much about safety, right? How are safeties handled? Traditional systems also have safety ahead of I/O cards. In general, it's a good question, right? I did mention that we integrate with our existing TwinSafe products, right? That's part of that. I think from a design standpoint, when we move to, I'll take an example like safe motion, right? We moved to servo drives that had built-in safe motion, right? It ended up moving some of these components, the contactors and feedback side of things there from the safety. We ended up moving it into the component itself. It's kind of the same idea, where we're going to move everything into that module, for example, the servo drive, and handle safety in there. We've got the kind of the traditional safety TwinSafe side of things for us for I/O, as well as the PLC capabilities there, the TwinSafe control side of things being part of that. So that is something that's integrated into that system as well. I think those are all really great questions. Other than that, that probably wraps up the ones that I'm going to be able to cover right off the bat here. In the meantime, as we move forward here, this last page, we've got a QR code here for the webinar series registration. So these are our Webinar Wednesday webinars. You can scan that to get access to previous ones and get access to sign up for future ones. We also have our contact information here to be able to contact us. So some closing thoughts, I guess. Once again, I am Brandon Snell at Beckhoff Automation USA. If you'd like to learn more, feel free to reach out to me or your local team. And I really appreciate your time today. Thank you all for everything, and look forward to meeting you.